Hello, welcome to our Mathematics Expert Academy. If you are a new viewer, please subscribe. All right, let's dive into a mathematical tool that can seem a little tricky at first, but trust me, it is incredibly powerful. We're talking about the logarithm. By the end of this, you'll see it's not some complication, but actually a key that unlocks a whole new way of looking at the world. So, we're all pretty comfortable with powers, right? If I ask you, hey, what's x in the equation 2 to the power of x equals 8? You know right away the answer's 3. Easy. But what if I ask you to solve 2 to the power of x equals 10? Suddenly it's not so simple. We know the answer has to be a little more than 3, but we don't really have a way to nail it down. Well, that is exactly the problem that logarithms were invented to solve. So here's our game plan. First, we're going to tackle the big question. What even is a logarithm? Then we'll get fluent in the language of logs, see how to actually solve problems with them, and then discover some really surprising ways they're used in the real world. And finally, we'll wrap it all up with your own personal logarithm toolkit. Okay, first things first, let's crack the code. What in the world is a logarithm? I promise it's much, much simpler than it sounds. Okay, check this out. At its heart, a logarithm is just another way to write a relationship you already know inside and out. We're used to the index form, right? 2 cubed equals 8. The log form over here says the exact same thing. Log base 2 of 8 equals 3. They are literally just two sides of the same mathematical coin. So here it is, the big secret. Logarithm is basically just a fancy word for a power, or an index, or an exponent. It's the answer to one very specific question. What power do I need to raise this base to in order to get that number? That's all it is. If you remember one single thing from this section, please let it be this. A log is an index. Just say it to yourself a couple of times. A log is an index. It's the absolute key to understanding everything else we're going to talk about. Okay, so now that we know what a log is, let's learn how to speak its language. This part is all about flipping back and forth between index form and log form. The trick to converting is actually a super simple two-step rule. First, the base is always the base. It never moves, so the a in the index form becomes the little base of the log. Second, the other two numbers, they just swap sides of the equation. That's it. The base stays, the others swap. Let's just see that pattern one more time to make sure it sticks. If you have x to the power of y equals a, we just use the rule. The base, which is x, stays put. The other two, y and a, just swap places, and that gives us log base x of a equals y. It's a simple little dance that works every single time. All right, enough with the theory. Let's put these logs to work and actually start solving some problems. Let's start with one you can probably do right in your head. What is log base 3 of 9? Now, remember what the question is really asking you. It's asking 3 to what power equals 9? Go on, think about it for a second. You got it right. The answer is 2, because 3 squared is 9. Simple. But now, what about log base 3 of 10? Aha! We're back in that frustrating spot again. We know the answer has to be just a little bit more than 2, but we're just guessing. To get a real, precise answer, we're going to need a calculator. But here's the thing. If you grab your calculator, you'll probably only see 2 buttons for logs. One says log, and that is always, always log base 10. The other one says ln, which stands for the natural log or log base e. And e is just a special number in math. But neither of those is the base 3 that we need. So now what do we do? We use an awesome little tool called the change of base formula. This thing is like a universal translator. It lets us convert a log of any base into a fraction using a base our calculator can actually understand, like base 10. All it says is that the log of x in some base a is just the log of x divided by the log of a in whatever new base you want. So let's finally solve our problem, log base 3 of 10. Using the formula, we can rewrite this as log base 10 of 10 divided by log base 10 of 3. We can just punch that straight into our calculator. Log of 10 is 1. Log of 3 is about 0.477. Divide them, and we get our answer, roughly 2.096. No more guessing. Okay, so we can solve problems, which is great, but why does any of this actually matter? Well, because logarithms are one of the best tools we have for taming the wild, scurving data we see all over the real world. So imagine for a second that we're scientists studying radioactive decay. We measure the activity level of some isotope over time, and when we plot the data, we get this steep downward curve. Now, trying to find a simple equation to describe a curve like this is really, really hard. And here's the data we collect. Just look at how that activity level drops off super fast at first, but then the rate of decay kind of slows down over time. This is what creates that classic curve, which is a real pain to model with a simple equation. But now, watch this. This is the magic trick. Instead of plotting the activity level L, let's plot the base 10 logarithm of L. And look what happens. All of a sudden, that messy, complicated curve transforms into a perfect, predictable, beautiful straight line. This right here, this is the superpower of logarithms. And the amazing thing about straight lines is that their equations are super easy to find. We can see that the log of the activity level is just equal to negative 0.005 times the time plus a constant. Just like that, we've turned a complex curve into simple high school algebra. And for the final step, we just reverse the process. We take our simple linear equation and we convert it from log form back to index form. And there you have it, a precise model that perfectly describes the original curve. We took messy, real-world data and we made it predictable. That is the power of this tool. Okay, wow. We went from a simple question all the way to a powerful scientific model. Let's just lock in the key ideas so you can add them to your mathematical toolkit. So here are the 4 big things to remember. Number 1, a log is just an index. Say it with me. Number 2, index form and log form are just 2 different ways of saying the same thing. 3, the change of base formula is your secret weapon for your calculator. And finally, the superpower of logs. They can turn crazy curves into nice, simple, straight lines. And that leaves us with one final thought. We just used logarithms to make sense of radioactive decay. But think about all the other complex, curving relationships out there in finance, in biology, in technology. What other secrets could we unlock if we just looked at them through the lens of a logarithm? Thanks for watching.